Now we are going to discuss about the data warehouse modeling. What is the data cube and what is OLAP? As I mentioned before, the OLAP means the online analytical processing. It is related more in the data warehouse, and then the OLTP is the online transactional processing, or it is related with the transaction DB. Now we are going to learn about the data warehouse. What is the data warehouse? We call the data warehouse, it is from the database tables to data cubes. So a data warehouse is based on the multi-dimensional data model, which views data in the form of a data cube. So data cube, for example, sales is one of the example of the data cube. It can be modeled and it can be viewed in the multiple dimensions. We have later called as the dimension tables. What are dimension tables? We can see later is items or type. Item, it can be the item name or brand or the type, and the time, it can be day, week, month, quarter, year. And there are some fact tables. Later we will check what are the fact tables. So fact tables contain measures. For example, how many dollars that has been sold, and some keys to each of the related dimension tables. So we have two dimension tables and the fact tables. So in the data warehousing literatures, there's a concept about the ND base cube. ND base cube. So N means the number of attributes. D is the dimension. Because this is the base cuboid. The topmost 0D cuboid or 0-dimension cuboid, which hold the highest level of summarization, we call it the apex cuboid. So the base and apex. The lattice of cuboids forms a data cube. Maybe we will see from this very simple example. We can construct a data cube from this table. We have a daily transaction. Let's suppose we have the transaction 1, we have transaction 2. And this transaction is the combination of the customer, item, and location. Hong Gil-dong, it is a person name. Purchased LG TV 45-inch at Yongin Brands in 2020, January 4th, and he's paying 500,000 won. Il Chime is another person. Purchased Samsung refrigerator at 150i, this is the type, at Bundang Brands in 2020, March 7th. And she is paying 1,250,000. Okay. We can see the customer table. So the customer, we have C01 is Hong Gil-dong. This is the date of birth. C02 is Il Ji-ming. This is the date of birth. And C03, okay, this is the customer name, and this is the date of birth. This is the place they are living. This is the address. We can have an item table. The item number is I01, which is the Samsung refrigerator. And the item number I02, this is LG TV. The price in the catalog is 1.45. And the price of the LG TV is 600,000. And we can have also a location. So the first is the location in the Yongin Brands and the other is in the Bundang Brands. So we can make a sales table. The sales table is based on the transaction. We have T01, which is the transaction 1. The C01 is the Hong Gildo, because we can see here, Hong Gildo is the customer, and he bought the item 02, okay, LGTV. He bought the item 02, and he bought in location 1 in Yongin Brands. And he purchased on 2020, January 4th. And the amount that he paid is 500,000. Even though the price is small, maybe he got some discount, or maybe he used coupons or something. So the transaction 2 is the same. You can take a look on this one. Il Jimei. So she is the customer 2, C02. And then item 01, which is the Samsung refrigerator. And then the location is in the Bundang Brands. And then she bought the product on 2020, March 7, and then she pays 1,025,000. So each cell, okay, we call this is cell, contain the sales amount for a specific item at specific location during a specific time period. So we call this is the cell. We call this is the sales cube. This is a total sales of LGDV 25 at Yongin Brands in March 2020. Okay, because we have the item, the time, item, and location. So each dimension may have a hierarchy. So we will check what is the meaning by this hierarchy. When we design this kind of cube, it is a lattice of cuboids. So based on this concept, as I mentioned to you, we have the apex and we have the base. So the base is the 4 dimension. It represents the item, time, location, and supplier. The 3D or 3-dimension cuboids is the combination of 3 variables. So we can see the combination of item, location, supplier, or time, location, supplier, or time, item, supplier, or the time, item, and location. So in this case, we know that time is the most important attribute. Okay. We can have the 2D cuboids. So it means the combination of 2 attributes. Location and supplier, item and supplier, item and location, time and supplier, time and location, and time and item. Or we can represent it into only 1 cuboids. The supplier, location, item, and time. So this is the lattice of cuboids, the combinations of the attributes that we want to analyze. So in the conceptual modeling of the data warehouse, we can model the data warehouse into several dimensions. So we have several dimensions. We also can have measures, so we will check later about the measures, but now we are going to discuss about the dimensions. So the first is about the star schema. Star schema means a fact table in the middle connected to a set of dimension tables. What does it mean? Yeah, later we will see with examples. Snowflake schema. It is a refinement of the star schema where some dimensional hierarchy is normalized into a set of smaller dimension tables. So it will form a shape similar to snowflake. And the other is the fact constellation. It contains multiple fact tables that share dimension tables. So it is viewed as a collection of stars, therefore called galaxy schema or fact constellation. So let's see example. We call this is the star schema. The star schema here, we have the sales fact table. As you know, the first table that we have here, this is the sales table. So this is the fact table. This is the transaction that occurs and we want to put it into our data warehouse. So this is the fact. In order to find the details of this fact, we need to connect to the dimension table. So the fact table, it will be connected to the dimension table, dimension table, dimension table. So the dimension table here, because we have the time key, it is related with the time, whether it is the day, day of week, month, quarter, or year. It also connected to the item. The item means the product itself. We have the item key, we have the item name, brand, the type, and supplier type. And we can also have the branch key. So the first one, we can see that it is in Yongin or it is in Bundang. They will have a specific key. And we can also see the location. In the location, we have the location key. Yeah. Or maybe we have the details like the street, the city, state, province, and country. And we will have measures. The measures means how much the customers pay for products. So we have, let's say, the unit sold. So how many products that has been sold, and how many dollars that the product has been sold. And we can also see some of the measures like the average sales. We can have the snowflake schema. What is the meaning by snowflake? If you know about snow, this is the snowflake because we have the fact table, we have the dimension table, but we still have more detail. We have sub-dimensional table. We have sub-dimensional table for every dimension table. For example, I know the item. I know the item that has been sold in the branch. But I also need to know what is the supplier. So the supplier key is connected to another sub-dimensional table. We have the supplier key and the supplier type. Maybe here in the location, I have another key, which is city key. So it is connected to another dimensional table. So we have the city key, city, state, province, and country. There's another case, the dimension, we call it the fact constellation. In the fact constellation, there will be multiple fact tables. So the first is the sales, and the other is the shipping. So you know that this is another fact. After you know the sales, and then let's say they want the store to deliver the product, then they will have the shipping fact table. The sales fact table happening in the time and what is the item, where is the branch located, and where is the location, and you will see the measures here. For the shipping fact table, you will also have the time and the item that has been delivered, the shipper key. So it is different. The delivery person or the delivery companies. And we want to see from location and to location. because we want to deliver the refrigerator. And we have also the measures, how many dollars that it costs for the delivery, and how many units that has been shipped for that product. Because this is the fact constellation, because we have not only one fact table, but we have two tables for the fact tables. And for this fact table, it will be connected to another dimensional table. Okay. If you look back on the data transformation approach, there's a concept about the hierarchy. So every of this dimension, you can put it into the hierarchy. Let's say it is about the location. You can have the hierarchy like all, and then you will see the continent. It is in Europe or it is in the North America. If it is in Europe, then it is in Germany, Spain, and other countries. If it is in the North America, yeah, it will be in the maybe in the Canada or Mexico. Yeah. If it is in Germany, there will be another lower concept. We call it city. So it might be in the Frankfurt. If it is in the Canada, it can be in the Vancouver, Toronto. Okay, let's say in the Vancouver, there will be some offices. So the offices has been led by Al Chan, maybe this is another person. So we can have this concept hierarchy. For the measures, what is the measures here? As I mentioned to you, we can have these measures. How many products that has been sold? Okay. How many dollars sold? And what is the average sales? So in this data warehouse, we can distinguish the measures. We call it the data cube measures. And we can distinguish it into three different categories. The first category is distributing. The second is algebraic. And the third is holistic. Distributing. So if the result derived by applying the function to n aggregate values is the same as that derived by applying the function on all the data without partitioning. Maybe it is difficult to see the long sentence here, but the easy one, because this is just very simple function, just to see like the distribution. For example, how many data do we have? Count. And what is the summation? Or what is the minimum? What is the maximum? Okay. So it will just give you the measures for every cube on the respective data. The algebraic, if it can be computed by an algebraic function with m arguments means that m is a bounded integer, each of which is obtained by applying a distributive aggregate function. So we can apply this distributed function. Let's say we have count and let's say we have sum. We have count and we have sum. So we can do the average. Okay. If we want to make the standard deviation, then you will do the summation of the subtract value. Let's say I have xi and minus by x bar, which is the average, power of 2, and then we will do the square root, and then we will divide with the n. Okay. So this kind of algebraic function or the algebraic measures, usually it is based on the distributive function. And we have the holistics. If there is no constant bound on the storage size needed to describe a sub-aggregate. For example, median. When you want to measure the median, you need to sort the data. So when you need to sort the data here, of course, you need to have some space on the storage size. Once you sort, you will have another storage before you check the median. Or you can check the mode or the rank. Yeah, those are the holistic measures that require some space. So let's see if we have this data. Okay. The row 1, 2, 3, 4, and then I have 3 columns, column 1, column 2, column 3. So the minimum, these are the measures of the respective row. And these are the measures for the respective column. Okay. Now you can see 1 and 2 and 3. So the minimum is 1. And the count, there are 3 data, and the average is 2. Here we have the median. Yeah, the median is a cause of the sorting. After you sort the data, you will get the median. Here we have, let's say, the R3. We have the minimum is 2, and then the count is 3. We have 3 data. And then we have the average is 505 because 1000 plus 8 plus 2 and divided by 3. Maybe this one, not the average. 1010 divided by 3 should be 300 something. And it's this one. And the median, yeah, it is 8. It is the middle value. So this kind of measures are available in the DataCube measures. So you can take a look on some software. Yeah, this is one example from a software called as the dbMiner. If you want to specify the hierarchies, you can see the schema hierarchy like this one. So this kind of tree is the schema hierarchy. And let's say you have the any means all. And you want to see the Europe, Far East, North America. And when you click, yeah, it can show more detailed information. Here, let's say in the North America, when you click, you will see Canada, Mexico, and United States. And in Canada, you will see some cities, Montreal, Toronto, and Vancouver. And if you see the Vancouver, there will be some offices, like, yeah, maybe the offices led by Charles Dunham, the other offices led by the Harry Crane, and so on. So this is the view of the warehouses, and this is the hierarchies. And you will see this is the level name that you want to check. And this will be in the particular region. We can see this one as the multi-dimensional data. As you already see from the previous section, it is a sales volume, and we have 3 attributes, or it is a function of product. And then month it means time, and then region. So we have the dimension of product, location, and time. And for every of this one, we have the hierarchical summarization heads. For the product, we can have this hierarchy. So the product will have what is the category and what is the industry. Let's say the TV on computer, PC. Yeah. Maybe they are in the category of electronic products. So it will be correlated with the industry and the electronic industries. The region or the location, we have office, city, country, and region. For the time, we can have another hierarchy. If it is starting with day, there can be the month, quarter, and year, or it can be day, week, and year. So every aspect of this dimension will have the hierarchy. It will have the hierarchy. This is a sample of data cube. I think you already see many times. We have the products, we have the date, and then we have the country. So the TV is the product. I want to check the sales on the first quarter and the second quarter, the third quarter, or the fourth quarter, and in the respective country, either it is in USA, in Canada, in Mexico. So you can take a look on this brown color, on this green color, and also in this gray color. The green color, the brown color here, it represents the summation of this. The summation of the TV, you can look at from this side. If it is related with the country USA, so maybe the first quarter is in this side. So the USA is this row. If you look at the blue color, it means this is the summation from all aspects. It will show the aspect of the products and the date and the country. So returning back on the concept of cuboids that we saw before, 0D means the apex. And the total number of the attributes, we call it the base. So here we have the product, we have date, and then we have country. And then if we want to check only the two dimension, we can see the combination of the date and country, product and country, and product and date. If we want to check for only one dimension, we can have product, date, and country. And yeah, all it is the 0 dimension, or it is the apex. In the OLAP, there are some typical operations. I guess you already know the roll up and drill down. Sometimes it can be mentioned as drill up, and sometimes it can be mentioned as roll down. So roll up means to summarize the data. So when you learn about the data transformation or the data reduction strategies, here we call this concept roll up and drill down, and it is also useful for the OLAP operations. Roll up means we want to climb up hierarchy or by dimension reduction. For the drill down means we have the higher level and we want to go down to the lower level. So this is the high level summary to the lower level summary, or it is more on detailed data. Or we can introduce new dimension. Here another concept, we call it slice and dice. So we will project and select. Or yeah, we have pivot, which is rotate. We want to reorient. Reorient. It means we want to change the orientation. We can do the visualization, or we can change this 2D to, we can change from this 3D to 2 dimension. Some other operations we have drill across. It means we can involve more than one fact table. Drill through. It is through the bottom level of the cube to its back-end relational table using the SQL. So let's see if we are dealing with the drill up and drill down. I guess you already know. The drill up means you want to make the lower level data into the higher level. So for example, this one, I have the city of Lyon, I have the city of Nice. They all belong to the country France. We have Venice and we have Florence. They all belong to the country of Italy. If we do it, the drill down, for example, this is from quarters to months. So I have winter, spring, summer, and fall. So those are the seasons. So if we want to check on the details, we can down to the time, January, February, March, April, May, June, and so on. Okay. Slice and dice. For the slice, it means we want to, slice, okay, just cut. I just want to see only for the winter time. Okay, then you can just cut on winter time. So it means only the winter box will be selected and we will check based on the winter time. If you are dealing with the dice, it means you will have some box here. There is, this is the dice where the location equals to Venice or Florence and the season equals to winter or spring and the item either components or clothing. So you can select a particular box. What we call this is the slice and dice. And we can have the pivot. Pivot means reorient. Okay, reorient means change the orientation. First, the mobile, modem, phone, the security is in the x-axis. And the city, Chicago, New York, Toronto, and Vancouver is in the y-axis. So we can do the pivot by changing the location. So the mobile and modem phone security is now in the y, and the city is now in the x-axis. Drill across product and customers. So in the first part, we learned about the drill down, but in this, the drill across, let's say we have a fact table here. The product 1 has been sold 40 items. The product 2 has been sold 52 items. So I want to drill across. It means I don't have any data about the clients actually. So what I have is only the product and then the time and the country. So I want to know which client bought the product 1. So I can have the detail drill across for the client. So I can check that the product 1 has been bought by client 1 for 5 items and client 2 for 35 items. So it is 2 different fact tables. Got drill across. Or we can also do a drill through. Okay. Drill through means if we look at this revenue, it is belong to the America. But I want to know more if it is in the Americas. What are the products that have this revenue? So with the orientation, with the SQL, we can check that this is the product in America that has been sold as amount of this revenue. So it is still through summary report to a detailed report showing revenue break up by the product line. So we have different attributes. The first is the total on the continent, but the other is the total in the product line. We can see it as a StarNet query model. This StarNet query model means, if you look at the product contains of the product item, and there will be the higher concept, which is the product line, and there will be the higher, which is the product group. In terms of customer, we can have the order, or some customer might do the order with the contract. In the organization, we have the salesperson. The higher concept is the district, and then we have another higher concept, which is division. In the terms of location, we have the first is city, and then we have country, and then we have the region. For the time, we have daily, quarterly, annually, and for the shipping method, we can have the truck, and let's say we have the air express. So you can make the StarNet query model by linking what you want to see. So in this case, I want to see the product group on a particular district in a specific country on a quarterly basis, and when the customer order is a contract base. So if you link all those, then it can show from your data warehouse, and you can use it for your analysis. So in the data warehouse, you can do with the visualization. You can browse the data cube with the visualization. Let's say here, okay, I know that this is the biggest one. Then maybe you want to spot on this big cube and you want to analyze more. What is the product here? And what is the location here? And what is the time when the revenue comes with this product? Okay, so this kind of visualization will give you more confidence to analyze your data. Or you can also use the OLAP capabilities. Maybe you can do some SQL and then you will look at this visualization and more. So some of the data warehouse, they can show this interactive manipulation. Okay, just have 1 more minute for discussing this one. How many dimensions are there in the data warehouse? So we already learned at least there are 3 dimensions. If you check on the schema, we have the star schema, and then we have the snowflake schema, and then we have the packed constellation. We have another one at the end. We learn about the StarNet query model. We can look at the proper details, what you want to create on your data warehouse. How many methods are there in the data warehouse? We learn at least 3, which is distributive, and then we have the algebraic and holistic. Can you mention the typical OLAP operations? You learn about drill down or drill up. You learn about scroll down, and then you have roll up or drill up, and you learn about the slice and dice. There is another operation, we call it pivot. There's another operation, we call it drill across, and there is another operation, we call it drill through. Okay, So those things that we learn on this section. Okay, I guess I need to stop here due to time. Any questions, comments?